So we are going to discuss the mains pattern test that is held on 1st November 2020. So let us discuss the questions related to the chemistry. We'll say that question number 26 we'll discuss it. So question 26, it is given to us, that is the EMF of the cell corresponding to the cell reaction which is given to us is 0. We can say that 169 volt at 25 degrees centigrade. Calculate the pH of the solution at the hydrogen electrode. Okay, so what we'll do, since the H plus sign is present in the QC of the reaction, we can calculate the H plus sign concentrations. The E naught of the cells are mentioned to us, so we can calculate the EMF. We can calculate the, we are given the EMF, we can calculate the E naught of the cell. So we'll write that. By Nernst equation, we can say that E cell will be equal to, that is E cathode minus E anode, minus E naught of anode, minus 0.0591 upon n into log of QC. We can substitute the values directly, that is, this is given to us 0.169. This will be 0.76 minus 0, that will be like this, minus, we can write that, that is, so we can directly write that, no need to write, we can write that E naught of the cell is this, 0.0591 upon, we can write that, that is 2 given to us, log of the concentrations. Zinc ion is mentioned to us, partial pressure of H2, it is a standard electrode we know that, and the concentration of H plus zinc square. Now in the questions we are given to us EF इनको 1 given है, this is given to us as 0.1, this is given to us EF इनको calculate कर लेना है. We will calculate the H plus ion concentration and we'll get the answer. So from this we can write that, that is the pH of the solution we can calculate. We can calculate the H plus ion, then from the H plus ion we can get the pH of the solutions. So we can directly calculate that. The pH of the solution will be, we can say that directly, we can get the answer from this. We are given 0.1, we have to calculate the H plus ion, so we'll write that pH will be equal to 10.5 we are getting. That is for the question number 26. We are given that what will be the volume of, next question is 27, in 27 we have to calculate, 27 we can write, what is the amount of chlorine evolved when 2 ampere of current is passed for 30 minutes? We can calculate that by using the Faraday's law. Weight upon equivalent weight will be equal to Q by 96500. So we have to calculate the weight and equivalent weight of chlorine, that is 71 divided by, that is 2. Q is given to me, that is I into T, so I the ampere is given to me 2 amperes and we are given 30 minutes. Multiply by 60, you will get the seconds, 96500. You will get the weight of this. The weight of this, what we get is 1.32 grams. That is how we calculate the weight. You can calculate the question number 28. In question number 28, we are given that the primary and the secondary valencies of the chromium in the complex ion. So we can write that dichlorido, oxalato, and chromium 3. That is the compound given to us. So we can write that chromium dichlorido, so that is Cl2, and dioxalato. We are given that dioxalato, yes, C2O4 2 negative. So we can write like this. We can say that now in this case we are given that the oxidation state, if we calculate, so from this we can write that if this is plus 3, we know that this will be the example we are having. So this will be twice. Now we are able to tell that what will be the, we have to calculate that what is the primary valency. The primary valency which is responsible for the oxidation state, it is plus 3. The oxidation state of central metal is called the primary valency, and the coordination number is called the secondary valency. So primary valency will say that will be 3, and the secondary valency will say that will be 6, the coordination number. So it is equal to coordination number, and this will be equal to oxidation state. Okay, we can write like this. Question number 29 we can write. In which of the following reaction acetone is not formed as the product? In the first reaction, it will be formed. Yes, because in the first reaction, we know that you're going to add water according to the Markovnikov's rule. So on tautomerism, we'll get that. Option A. Option A, we'll get that it is, we have studied in ORM 2, the same reactions. B, we can write that it is ozonolysis. So we are going to get that. On ozonolysis, that is the reductive ozonolysis, we'll get like this, that is the acetone which will be formed here. Then we can say that the option C is there. Option C may we are given that MnO2, yes, we'll say that if we reduce MnO in MnO at 300 degrees centigrade with acid, we'll get the product as acetone, we know that, plus CO2 plus H2O we get. That is the product what we get. In the last case, it is aldol condensation, but in D case, it will be aldol condensation. So D is a aldol condensation, CH3CHO. We are given that. We have to take twice, and in the basic medium, we'll get that. The aldol condensation reaction will be like this: double bond CH and CHO. That will be formed. This is aldol condensation product. On heating, what we get. So the answer will be D in that case. We'll say that. Next is question number 30. We can say. For question number 30, we can write like this. That is, we are given that. For question number 30, we can say. The question number 30 is given to us as, that is CH3, CHO and Cl. So that is 30, we are given like this. So in this case, the products are, we have to check. Okay. So we are given that CH3, CH double bond O, that is cyanohydrin will be formed. HCN के साथ react करेंगे तो we'll get that CH3, CH, OH and CN will be formed. That is cyanohydrin. Right? We'll get the cyanohydrin. And after that, it is dilute NaOH. We have to treat this with the dilute NaOH and then hydrolysis. So on dilute NaOH and hydrolysis, we'll get the product as, right? This will be the enantiomers. और इसका base hydrolysis करेंगे, that is NaOH. So after base hydrolysis, I'll get that CH3CHOH and CH3CONa will get like this. And on hydrolysis, so this will also be an enantiomers. This will also be an enantiomers. And on hydrolysis, we'll again get the enantiomers like this. That is CH3CHOH and COH will get that. Beat, that is alpha hydroxy carboxylic acid. Carboxylic acid is formed. So that will be the product of the reaction. Again, in question number 31, it is that is ozonolysis. We are given question number 31. We are given the product as, there is a 6-membered ring. We are given the ring there. That is a 7-membered ring is given to us. So the 7-membered ring will be like this. We are given that. If we go for ozonolysis, that is reductive ozonolysis, we'll write like this. That is, we'll get one aldehyde and the other will be a ketone. So we'll get that the number of carbon atom, that is CH3, C double bond O. We'll get double bond O. Then CH2. 1, 2, 3, 4, 5. 5 CH2 will be there. So I can write that CH2 whole 5. We can get that CHO. That is the product what we get. Now, if we get that product, we can write that. After that, what is that? Dilute base and like this, and then it is heated. So it will be an aldol condensation reaction. So in the aldol condensation reaction, what I can do, I will get the 5-membered ring because it should be like this. So it will be 1, 2, 3, 4, 5, 6, 7. So one more CH2 will be there, then C double bond OH will get like this. So here we'll form a anion. We'll say that the base will react with this. Base will form a anion here. Then we'll show the aldol reaction. After the aldol condensation, on heating, what I'll get is, we'll get a 1, 2, 3, 4, 5, 6-membered ring. I'll get a 6-membered ring like this, and I'll get C double bond O, CH3. Then the dehydration will get a product like this on dehydration. So on dehydration, we'll get the product like this. That is how we can get the product of the reaction. So that is the product of the reaction we'll get in question number 31. Then we can say that question number 32. If we talk about the question number 32, we are given that in question number 32, in which of the following reaction the final product neither acid nor a salt? In the first case, in A, the answer will be that is a salt because it is a Tollens reagent, so it will be a salt which will be formed. In the second case, again it will be a, we'll read that in case of B, the product will be CH3CO negative, the basic medium. In the third case, it is a Fehling solution. Aromatic aldehyde doesn't give Fehling solution, so no reaction because aromatic aldehyde do not give Fehling solution. So we know that the product of the reaction will be here will not get any reaction. So we'll say that there will be no reaction. It will remain aldehyde. And in case of D, it will form a carboxylic acids. Okay, so there will be PH, COH will be formed. This will be the product. Aromatic aldehyde doesn't give Fehling solution reactions. We can take 33. In case of 33, we are given that which of the following is true about the complex. We are given the complex. Which of the following is true? We have to write. So the complex given to us is PtCl2 NH3 and H2O. That is given to us. So I will say that since it is a platinum, we know that D8. So the electronic configuration will be D8. So therefore, I will write that DsP2 will be the hybridization. If it is DsP2, we know that it will be a square planar right now bipyramidal, like that we can write. So I can say that on the basis of Cl2, I can write that it will form a cis and trans isomer. We can get geometrical isomers. It will have two geometrical isomers, cis and trans. Yes, it is, because on the basis of Cl, we can write cis and trans. The hybridization state is sp3. No, in case of platinum, since the electronic configuration is D8, so we'll write that it will be right because it will be 5D8. So we can write that and the ligands are given to us already. We know that if it is a 5D or 4D elements, then central atom, then it will always form a inner orbital complex. It can show hydrated isomerism. No, it cannot show the hydrated isomerism because there is no other, because coordination number, we cannot change the coordination number 4. It is a tetrahedral complex, it's wrong. Question number 34, we are given that in 34 we can say in which of the following complex the metal ion will have T2G6 and Eg0. So for a T2G6, I require strong ligand and the coordination number is 6. Now coordination number is equal to 6 and a strong ligand. Strong ligand must be present. Okay, so we'll say that 1 cannot be the option, 2 can be the option. Let us check, but there should be 6 electrons in with iron. So Fe is, we know that what is Fe? Fe is 3d6 and 4s2. 3d6 and 4s2. If I require 6 electrons, the oxidation state of iron must be +2. So in case of second option, the oxidation state of iron is +3. It cannot have 6 electrons, so that cannot be the option. But in case of third option, there is a strong ligand as well as the oxidation state of iron is +2. So I require the oxidation state of iron is +2 because it will be 3d6 for its 0. So the 6 electron can be filled in T2G if the ligand is strong. Next is we can write that in question number 35. RCl when treated with KCN, we'll get that RCN, and the RCN when lithium aluminum hydride, we know that it will reduce to give RCH2NH2. That is the product of the reaction. So option will be 2. In question number 36, it is a reaction. We know that the chemical reaction in that case. Question number 36, we can write like this. In case of 36, we can say that there is one 7-member ring and the other will be the 5-member ring. So I got a 5-member ring and the other will be the 7-member ring. And in this case, we are given that this is like this, and here it is oxygenating. We know that when we treat this with the acid, when you treat this with acid, we'll get like this, positive charge on this. We all know that we cannot break this bond because it will form a anti-aromatic, so we'll break this bond because it will form an aromatic cation, which will be stable. So oxygen 18 will be present with the 5-membered ring. We can write the option as 2 because there is right now 5-membered ring with that. Question number 37. In question number 37, we can say that it is a Mons process. Mons process already we must have discussed in that is a vapor phase refining in of metals. Mons process where Ni with other metals when treated with carbon monoxide at 60 to 80 degrees centigrade. Maximum it will be 80, less than 80 it is. So we get the gaseous phase compound, that is nickel carbonyl, and on heating at around 150 degrees centigrade it get converted back into the nickel and the carbon monoxide will be liberated. That is the product what we get. Next we can write as, so it is a Mons process for the vapor phase refining of nickel, we know that. Next we can say that one of the product on heating with dilute nitric acid and copper and zinc relatively are. So copper and zinc relatively are, we know that if it is a concentrated H2SO, HNO3, then in that case with concentrated HNO3, we know that the product, the gas liberated is NO2 always. But with dilute, it will be either N2O or NO. With zinc and Fe, it liberates N2O, whereas with the other, we say that copper and right now other it liberates NO. So we can read that this is a fact that if it is a concentrated HNO3, then doesn't matter which element is present or a metal is present, it is always liberating NO2. But in case of dilute, there is with zinc and Fe it liberates N2O, whereas in other cases it will be NO. So in case of zinc, and that is we can say that we can easily check that if we treat a metal with a right now copper or that is right now HNO3, we'll get that metal nitrates NO3 whole twice, we'll get that it is copper, so we'll get NO plus H2O, that will be the product. But if it is zinc or iron, it will liberate N2O. That we have studied in the 15th group element on reaction of HNO3 with metals. In case of 39, we can write that. We'll write the relation between the two molecules that is given to us, that is COH. OH and H, that is also OH and H, and this is COH. We can write this as we are given like this, that is NH2 in this case. This is NH2, here it is NH2 which is given to us. So we can write that this is NH2, this is COH, and this is H, and this will be OH. This is OH and this is H. So if I have to find out the relation between these two, I'll check that what would be the electronic configuration of these cases. So I will write this here and then I will calculate the electronic configuration. Right? So if I check in this case, it will be 1, 2 and 3. So I'll write that in this case, this is R. So I'll write S. Here it will be 1, 2 and 3. So it is S. So I'll write the R. Here it is R and this is S. So I will write that they are enantiomers. I'll just check once this part. 1, 2, 1, 2, 1, 2, that is 2, this will be 1 and this will be 2, then that will be 3. So 1, 2 and 3. So this is S and this is R. So I think there is these two are not the enantiomers we are having. So we will say that just I will check once more. This is 1, 2 and 3. So I am getting S, I have written R. Here I will write that 1, 2 and 3. So it will be 1, 2, 3. There is S, so I will write R. Here it is 1, 2, 1, 2 and 3. So that will be R. So I have written S, and this will be O. Here it is S, here it is R. So I will just write here. This is 1, 2 and 3. So it is S, I will write R. So they are, I think this is diastereoisomers, because this is RR, this is not SS. If it is SS, then we'll say that it will be a, right, I can bring this here as a, we can write this here. Then we can say that this is mirror images, and this will be also a mirror image. If I write here, I'll get that it is OH and COH both are changed, so it will be the same. I think it is diastereoisomers. Then we'll say that in case of 40, I don't think we have to write that, because we know that which statement is incorrect about the graph. In the graph, there are 1, 2, 3, 4 peaks. It means that it has 4 transition states. And the values in that graph, we know that if we are given the values like this, so these are the transition state, these are intermediates. These are intermediates. So there are 3 values, 1, 2, and 3 values are there. So we can say that that is having 3 intermediates and the 4 transition states. It is exothermic because the energy of the product is less than the energy of the reactant, so it is exothermic. So we know that. Option 1 is correct, option 2 is correct. The number of intermediates will be 3 in the according to that graph, and the number of transition states are 4, that is correct. In case of 41, that is the reactions are given to us. That is, we know that that reaction is called Baeyer-Williger oxidation. In Baeyer-Williger oxidation, we used to add, in Baeyer-Williger oxidation, we know that there is a migration of group, and the larger the alkyl group, more will be the migratory ability with the per acids. So we are given the per acids. So we are given that the per acid is RCO3H. So the larger the group, more is the migratory ability. That will be the product for us. This will be the product. That is a Baeyer-Williger oxidation. We know that. Then used to convert alkyne into alkene, then it is a selective reduction. So generally we use Linder's catalyst, Rosenthal reduction, Wilkinson catalyst like that, no? Or a P2 catalyst. But here we are not given those, but yeah, it is calcium carbonate and PDH2. That will be Linder's catalyst. So we'll write the option is 2. It is a Linder's catalyst. Question number 43 is given to us. That is the what is the pKb value? pKb value for what is the pKb value for lambda at infinity for ST type if lambda at infinity is given to us. So lambda at infinity, and we are given 40 to 43. So we can calculate alpha because we are given that lambda at a given concentration divided by lambda at infinite concentration. That is 7.8 divided by that is 390. So we are given the alpha. We can calculate the Ka value for that. Ka will be equal to, that is for acetic acid, Ka will be equal to C alpha square. So C is given to us 0.04 na? Yes, 0.04 into alpha is given to us. So alpha comes out to be 2.10 to the power minus 2, will get that. So we tried the square of that. So I got that Ka will be equal to, that is 16. So 1.6 into 10 to the power minus 5. Therefore pK will be equal to 4.8. If pK is equal to 4.8, we know that how to get the pKb for that. So we are given that pKb for ST type. Yes, we can write that ST type, pKb for the ST type. That is equal to pK for acetic acid. We can write that in the question number 44, we are given that. In 44, we are given that CH3, that is a benzene, CH2, CH3, that is given to us. We'll say that we are treating this with NBS in CCl4. So that is the benzylic substitution. That will be like this. That will be Br and CH3. After that, we can write the P. So this will be the P which is formed. Now with the magnesium, we'll get the RMGX, and with CO2, it is called carbonation of organometallic compounds. So we can write like this. After hydrolysis, this is the product, and after this product, we can say that because in this case, we'll write that one more CH3 will be there. So it will be like this. CH3 and CH and COH, that will be formed. Then it is given to us, that is right, we are given that decarboxylation soda line NaOH plus CaO, and it is heated. So again we get the same product, CH2, CH3, and then it is given to us Br2, the two equivalents, we'll get the 2Br, 2 time benzylic substitution, 1Br, 1Br, 1 CH3. Then with alcoholic OH, and we'll get the alcoholic OH, we'll get the elimination reaction. So we'll get the product as, so S, this will be the product of the reaction. This will be the product of the reaction, what we can write. So in this question, we have to tell that what is Q. We are given the Q. This is the Q. No? P, then it is Q. So Q will be the major product of the reaction. So the carboxylic acid is not given to us. The carboxylic acid is not given to us. But before decarboxylation, this should be given to us. But the best option we can choose here is, because at least we have to form the Grignard reagent. So the best option, there is no option Q is not mentioned in the as a product, but we can write the best option will be this one, right? The best option will be the second one, because at least we can write the Grignard reagent. Which of the following is formed when a glycerol reacts with HI? We know that what is glycerol. Everybody knows that. What is glycerol? We can write the glycerol as like this. The glycerol is, we know that. If we talk about the glycerol, we can write the glycerol like this. That is question number 45. This is the glycerol. And if we treat this with HI, we'll get that H plus ion will attack on this, because this will form the 2-degree cation. So I can write the product like this. Get I here, then I'll write the OH. Then again we can write that it is, so it is written that excess of HI is given to us. Okay, so we can write that excess of HI is treated with that. So we can write that. If we treat with excess of HI, again HI, I will get that H2I, that is CH2I and CH2I. We know that iodine on the adjacent atom is unstable, so I can write like this. Again with HI, I will get like this. So these are unstable. The iodine on the adjacent atom will be unstable. So I got like this. Minus I2, that will be liberated, and CH and CH2I will be formed. Again, I will react this with HI. I'll get like this. CH3, CH and I, CH2I. Again, the iodine will be liberated. If the iodine is liberated, I'll get that CH3, CH double bond, CH2 will be formed. Again with HI, I'll get the product as, again the H plus sign will attack on this positive charge at 2-degree cation. We'll get the product like this. This will be the ultimate product what we'll have. This is how we can write the product of the reaction. We can write that the product of reactions. HI is a strong acid, so it can replace all three OH group, and we'll get the product like that. Next we can say is, that is question number 46 we can write. In question number 46, how many of the following alkenes can on hydrogenation gives 2-methylbutane? So 2-methylbutane, matlab butane is this and the 2-methyl will be this. I can write one double bond at this place, or one double bond at this place. So 2-methylbutane, how many alkene will give the 2-methylbutane? So I can write that for 2-methylbutane, we'll write like this here or here. It is one and the same thing. If we write like this, we'll get, again we can get 2-methylbutane, and if we write like this, then also we'll get the 2-methylbutane. These are the three alkenes. So it will be the three alkenes which will give us the 2-methylbutane. 47 we can write. The concentration of the alkyl halide is doubled and the amount of H2 is reduced to half. To the rate of SN1 reaction increases by. So rate of SN1, that will be equal to K into concentration of alkyl halide only. So if the concentration of this is doubled, the rate of reaction will double. It doesn't depend on the concentration of the solvent or the nucleophile. Therefore, I can write that it will be doubled. So the answer is 2. We are given that in question number 48, everybody knows that. I think this question is repeated many times. That which will be the most suitable position for the nitration? We'll say that at first position, the ring is not activated that much as it is activated in the left hand side ring is more activated on the right hand side ring, because in the left hand side ring where we are given the numbers, maximum numbers, this is 2, this is 3, and this is 4. Right? Here we are given NH, here we are given NH, but this NH is attached with C double bond O, doesn't matter. But this has 2 atoms which has a lone pair which can be stabilized. The arenemine which will be formed in nitration as an intermediate in the nitration. So the most suitable will be the 4th position. We'll write the answer as 4. Because of the plus M effect from this as well as from this group. Now the conductivity of the saturated solution, question number 50 we can write. The conductivity of the saturated solution of Cu2 FeCN whole 6 after subtracting the conductivity of water. Yes, so kappa is given to us. The kappa in the reaction is 1.28 into 10 to the power minus 5 per ohm centimeter per centimeter. Now, what is the solubility? Okay, we know that kappa, that is molar conductivity at infinite dilution, will be equal to kappa into 1000 divided by the solubility S. Now we only require this because kappa is already given to us. The kappa is already given to us, so we only require the calculation of, that is, molar conductivity at infinite dilution. That can be easily calculated because we are given the molar conductivity of we have to calculate the molar conductivity of what? Cu2 FeCN6. We require the molar conductivity of this. So what we can do to calculate the molar conductivity of this, you write that you are given the molar conductivity of copper. You require copper twice, so you can write twice of copper SO4. You require K4 FeCN6, so you just add K4 FeCN6. That these molar conductivities are given to us, and then we required this and this, but here copper is there, this is there. I have to subtract the copper and sulphate and potassium, so we can write that K2SO4. That is what I required. Now we are given the molar conductivity of copper sulphate at infinite dilution. We are given the molar conductivity of this at infinite dilution. We are given the molar conductivity of this at infinite dilution. If these values are given to us, we are able to calculate the molar conductivity of this at infinite dilution, and we can calculate that. So 2 into 260, we are given this 2 into 260 plus we are given that 720 minus we can write that it is 300. 2 into 300. That is what we have to solve, and we get the value as 640. 640, that is Siemens centimeter square per mole. That is what we get. Then we can substitute here 640. This is given to us. We can get the value of solubility. So therefore, I can write that it will be equal to, the solubility will be equal to the molar conductance of 640. 640 is equal to 1.28 into 10 to the power minus 5 into 1000 divided by the solubility is given to us. That is your value of solubility, and that S will be equal to whatever S we get is the solubility. That is equal to 2 into 10 to the power minus 5. So answer is 2. Connected that. That is what we have. This is your means pattern test. It's questions, the 25 questions what we have to discuss. That is all about this test. So I will give you the test analysis also. I will send you how many questions should be can easily be attempted and what should be the minimum marks we should get in this test. That test analysis I will send you. So that's all. Thank you.